Okay, 7.1 Intro to Sampling Distributions. Just to remember, a refresher that samples are subsets or they come from the population, with statistics are collected from samples, parameters are collected from populations. So we've kind of gone over some of these already with mean, variance, and standard deviation, but the statistics here that are coming from samples would be your X bar, your S squared, and your S. Your parameter that we're going to make some sort of comment on would be the mu, the sigma squared, and the sigma. A new one here is this p hat for proportion. That's kind of like saying probability would be like a sample probability from, or the probability from a sample. This is the probability from a population. So statistics from samples, parameters come from populations. Okay. We use statistics to make inferences about population parameters. Principal types of inferences, we can do an estimation. That's kind of what we'll be doing with the normal curve and this chapter and the next. Testing, hypothesis testing, you can formulate a decision about the value of a population parameter from that statistic. And then regressions, that's kind of the last thing we'll do from here. You've done quite a bit with this before, but you can do line of best fit, linear regression, even quadratic regressions, cubic regressions, to kind of forecast some sort of statistical variable. Okay, now a sampling distribution is a probability distribution of a sample statistic based on all possible simple random samples of the same size from the same population. So as long as I grab from the same population, so say the population is the entire school, and I grab the same size, say n is equal to 30, I can make a distribution out of those particular averages that I get, or samplings. Now, I'm going to make this a lot smaller. I'm now going to give a population of 6 numbers, and I'm going to grab 2 of them at a time. And I'm going to keep grabbing 2 of them at a time. By the way, I'm going to do this with replacement, and I'm going to look at those 2 numbers. Now, I can get these possible outcomes. I can get a 1 and a 1, a 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 2 and a 1, 2 and a 2, and so on. If I were to work that out, there ends up being 36 possible samples that I get. Now, in each sample, I'm going to go through and I'm going to write the mean. So add the 2 and 1s together, divide by 2, I get 1. 1 plus 2 divided by 2 gives me 1.5. 1 plus 3 divided by 2 gives me 2. Now, there are some chances that I'll get a mean of 1 again, or 1.5 again, or 2, or 2.5, and 3. And just to save some time, I went through, I calculated all those means, and this is what I came up with. I get an average of 1 on one of those 36 possible outcomes. Okay, 1.5 happens twice out of the 36 outcomes, and then you can again read through all those. Well, what I did is I took those possible outcomes, I put all the averages on the x-axis, and I put the probabilities on the y-axis, and I got myself a histogram. Okay. So each of these rectangles stands for the area of a probability of that possible average. Now, if you look at it, it kind of has this nice little bell shape or symmetrical look to it. Okay. How that's going to help us out is I'm going to eventually try to fit a bunch of these rectangles underneath a bell-shaped curve. Now here I don't have that many rectangles, but eventually I might get a lot of rectangles. So as a sample, as the number of samples and the size of the sample, the size of the sample is kind of a big one, get larger and larger, it's more and more likely that I'm going to fit those things underneath the bell-shaped curve, and then I get to use the normal curve as an estimation. And later on, we'll talk about this theorem called the central limit theorem that makes our life a lot easier if we get a big enough sample. So again, hopefully you're going through and at least looking through these. Page 365, 1 through 8, I check out those problems. Do them on paper, go through them in your head, something, but come prepared to work on some of these problems in class.